Molarity is the number of moles of solute per liter of solution. We use capital M for molarity and make sure that it's capitalized because the lowercase is something different. In an example problem, here we have 1.56 grams of a compound. What we want to do here is we want to convert the grams into moles. HCl is 36.5 grams per 1 mole. And once we have the number of moles here, we'll divide by a solution, the total volume. So this has to be in liters. The number of moles. So we'll do a quick calculation here. We have 1.56 divided by 36.5. And that's going to give us 0.0427 moles. Okay, we also have the number of milliliters. We got to convert that into liters. Move the decimal point over 3 places. 1, 2, 3. So that is 0.0268. So then we'll divide this out. And we end up with a molarity of 1.59. And you can just use that capital M. Whoops. Try that again. Alright, next. If we have a solution of calcium chloride and we want to look at how it dissociates, it gives us 1 calcium and 2 chloride particles. We can find both the concentration of each of these. So how I think of it is this, that we have 0.25 molar calcium chloride, and then gives us 1 of these and 2 of these. So since this is a 1-to-1 ratio between these two, it's still 0.25. However, it's a 1-to-2 ratio between calcium chloride and chlorine, so we need to double it. So it's a 1-to-2 ratio. So I'm going to take 2 times 0.25, and that gives us 0.5 for that one. Okay, another calculation here. We already know the molarity, and here we're looking for the number of grams. So there's two different types of approaches that you can use for this. You can use an approach that's very algebraic. I can show that to you. So here we have 2.7 is the molarity, and that equals the number of moles per liter. We know that there's 50 milliliters, so that's 0.05, and we do not know the number of moles here. So we can solve for x. X would equal the number of moles of this substance, HCl. And we would do that by taking 0.05 times both sides. That would cancel out here. We'd find out what x was equal to. So we'd have 0.05 times 2.7. And x is 0.135 moles of HCl. The next step is we got to convert grams into moles. 1 mole is 36.5 grams. And so the number of grams would be equal to 4 4.23. Let's double check that. That's not right at all. 4.93, excuse me. I knew I'd remember that wrong. So 4.93 grams of HCl. That's one way to do the problem. You can also do it in a way that's a little bit more dimensional analysis based. If we know that we want to find the number of grams, and we know that it's 36.5 grams per mole of HCl, what we can do is we can start off with grams in the numerator and do dimensional analysis. Now I've got to get rid of moles, and I'm going to multiply then by the molarity, which would have, remember that capital M is really moles per liter. And you can write 1 or just the unit liter, and then moles cancel out. Now we have liters. We want to get that to go away by multiplying by the number of liters. So here we go, and you'll get the same answer, 4.93 grams, when you multiply all the numbers across the top. You don't need to divide by 1. Okay, here's another type of a problem. It says, what would the concentration be if you use 27 grams to make 500 milliliters? Again, I'm not going to go through this problem entirely because I think that the idea is pretty clear, but you'd want to convert your grams to moles, and then next you would divide by your number of liters of solution. The concentration of the ions, when it's calcium chloride, we get 1 calcium and 2 chloride. So whatever you find for the concentration of the molarity, I'll just call that M here. This is also going to be M. This is going to be 2 times whatever you get for the molarity. So keep that in mind, please. All right. Here's a quick question about the concentration of ions overall. And I want you to look specifically at the types of compounds that we have. When we have sodium chloride splitting up into particles, we end up with 1 sodium and 1 chlorine. And I'm looking for what's called an I value. Okay, sodium splits up, or sodium chloride, excuse me, splits up into 1 sodium, 1 chloride. So the I value equals 2, 1 plus 1. Here we end up with 1 calcium and 2 chloride, so the I value equals 3. Here we get 1 and 3, so the I value equals 4. And sucrose is covalent. We could also call that molecular. And the I value for all of those is always 1. So what we want to do is account for the I value. Notice here that the molarity for all of the compounds is the same. The volume is what's different. So if you take 400 times 2, you get 800. Okay? 300 times 3, you get 900. 200 times 4, you get 800. And then 800 times 1, you also get 800. So just a quick way to think through which one produces the most ions in solution. And the correct answer is B.